Okay, so in the last class we discussed about truth tables. So today we will take some exercises with truth tables. Now truth tables are basically called as decision procedures. So these are not proofs but rather decision procedures. Decision procedures which help us to find out what is the truth value of a statement, as well as if we have an argument. So we can test its validity or invalidity, or we can decide whether an argument is valid or invalid with the help of truth tables. So there are two purposes which are served by truth tables. First is to check the truth or falsity of statements. So this is the first thing. Sorry. Second thing is to check the validity or invalidity of an argument. So these are the two things. So in the first part of this lecture, we will try to check with the statements, that how statements are checked and how we decide whether a statement is a contingent statement or whether a statement is a tautology or whether a statement is a contradiction. And in the second part of the lecture, or maybe it will be the second lecture, we will check how arguments are tested, whether an argument is going to be valid or an argument is going to be invalid, and so on. So that will be a very interesting exercise. And as I told you in the last lectures, that in logic we learn a lot through solving questions. We learn a lot through going through the exercises, and therefore I told you that we will be having two types of lectures. First lectures will be concentrating on the theoretical part, and second type of lectures will be concentrating on the questions part. So since we have now enough of understanding of few basic concepts, so we can try now to solve a few questions in order to understand what will be the basic of it. So let us start with statements. We can start with a very simple statement. We will see also what and how the truth tables are prepared, because sometimes students have always said that it is a little bit difficult for us to draw the truth table, how to draw the truth table, how the things are to be kept. There are more than one possible way of drawing truth table. In fact, there are many possible ways. People draw it with different techniques. People use different conventions for drawing the truth tables and so on. And the whole thing lies with the simplicity. First, we will learn how simple truth tables are drawn. First, as soon as we understand that how a simple truth table is drawn, we can go for more complex truth tables. But in order to give you a very basic, like suppose if we have three propositions, like suppose if we have to draw a truth table with P, Q and R. So the number of rows and columns, if you see, will be always 2 raised to power n, where n is the number of propositions. So here the number of propositions is 3, so it will be 2 raised to power 3, that will be 8 rows. Fine. If we have 2 propositions, so it will be 4 rows. If we have just one proposition, so it will be 2 rows. If we have 4 propositions, so it will be 16, and so on. Now, as you can see, or as you can understand, that if the number of propositions increase, right? Like suppose if we have a question, if we have a question with say 8 or 10, so you can see the number of rows, how many number of rows will be there. So that will become pretty difficult. But with say 3 or 4, it is quite simple. Even till 5, I will say, it's pretty simple, and we can draw, and we can also test the validity as I told you. But right now, for the first part, we will be concentrating on how to solve questions for statements. Okay, so with the help of truth tables, we will solve how and what are the requirements, or how to draw a truth table and so on. The construction of a truth table is important, because first thing is that we should learn the way of drawing a truth table, and second is how to test whether a statement is contingent or whether a statement is a contradiction or a tautology. Like for that matter, how questions come. Questions will come like this, like they will say that show P dot Q which R is a contingent proposition. Suppose if this question has come, Now this is our first question, that show P dot Q wedge R is a contingent proposition. So what should be the method of solving it? So let us make the truth table of it. You note the question, how to solve. For solving, we make P dot Q and P dot Q wedge R. So this is going to be our truth table. As you can see that there are 3 propositions, so there will be 8 rows. So how to draw the rows? We know there will be 1, 2, 3, 4 truth values, 4 false values. Then here there will be 2 truth, 2 false, then 2 truths, then 2 falses. Here P, Q and R we have. So we have another one, R. This is true, false, true, false, true, false, true and false. This is the thing. Now we have to draw. So since we should not confuse, I am drawing the lines. So we know that which line corresponds to which line. So it's pretty simple, just that we need to have a little bit of practice about it. So we will draw the lines so that our clarity is there. And the last one. So I'll keep it like this. I draw some lines here. And so on. So this is what we have to measure, or we have to calculate. Now P dot Q, the truth value of P dot Q. So we have to see the conjunction. We know already the conjunction. So the truth value will be, this is true, 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 true. This is also true. True and false will be false. Then true and false will be false. Now as you can see, all are false. So we can put false, 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 false. And now we have to find the truth table of P dot Q wedge R. Fine. So true and true is true. True and false is also going to be true. False and true is true. False and false is false. False and true, true. False and false, false. False and true, true. And false and false, false. Fine. Now, this is the truth table which we have prepared. Now, once we have prepared the truth table, we have to check. And as you see the question, in the question they have said that prove or show that P dot Q wedge R is a contingent proposition. Now, what does it mean when we say something is contingent? If you remember, contingent propositions, contingent propositions are those propositions which can be either true or false. Tautologies are always true and contradiction is always false. Now, if you have to show that this statement, this is one statement, this is another statement, this is another statement, so it is a complex statement, as we have discussed in the last class. So this is a complex statement, and we have to find whether it is a contradiction, whether it is a tautology, or whether it is a contingent proposition. Now, as you can see that there are 3 values which are true, then one is false, then there is another true, then there is a false, then there is a true, there is a false. That means it is a mixture of true and false propositions. What does it say? That this statement, P dot Q wedge R, is a contingent proposition because we do not find all of them to be true, all of them to be false, rather than some of them are true and some of them are false. So that means that it is a contingent proposition. So you can say that by the truth table shows that, or the value of P dot Q wedge R shows that it is a mixture, or it is a combination of true as well as false propositions, and therefore this statement P dot Q wedge R, which is a complex proposition or which is a compound proposition, is a contingent proposition as well. Okay, now let us come to the second question. The second question asks us to prove P P implies Q implies P is a tautology. Now how to prove this? Now the first thing which you should notice is that there are only two simple statements, that is P and Q, or two things which are there. So it will be a simple table of 4 rows. So how to make it? We have P, we have Q, we have Q implies P, because this is something which we have to, because it is in bracket, so this is the value of this has to be calculated first, and then we will calculate the value of P implies Q implies P. So this is going to be the truth table. So I put it as true, true, false, false, true, false, true, false. Now Q implies P. This implies this. We have to check. So true implies true is true. False implies true is true. True implies false is false. And false implies false is true. This is the thing. Now we have to check P implies Q implies P. So true implies true is true. True implies true is true. False implies false is true. And false implies true is again true. So now if you see all the values of this, all the values of P implies Q implies P has come out to be true. So now you can see that it is a tautology. So P implies Q implies P is a tautology. So this is how this table is prepared. There can be many ways of solving these type of questions. People also solve it in another fashion. Let me give you an example. Like suppose we can draw a truth table like this. We can just write this one, like I just make it a little bit of spacious and make it like P implies Q implies P. Now I make it like this. Fine. Now I know what will be the truth values of P. P's truth value is true, true, false, false. Q's value is true, false, true, false. P, true, true, false, false. Right? This one. I am directly solving this. Right? Now, first thing first, we have to calculate the value of this. So we know true implies true is true. We are finding the value here of this implication. So true implies true is true. False implies true is true. True implies false is false. And false implies false is true. Fine. Now I have to find the value of true implies this. Fine. So true implies true is true. True implies true is true. False implies false is true. And false implies true is also true. So you see, this is the value which we have to calculate. So this is a tautology. This is another way of solving this question. So as I told you that there are more than one possible way in which a truth table can be constructed as well as calculated. So one way is to directly draw all the things, then the separate parts need to be calculated, and then the final part is calculated. Another way is to directly draw the proposition. If you are a little bit well versed with it, so you can directly draw, you put the values in appropriate fashion, then you calculate the value because you know the bracket has been here, so you need to calculate this value, then you will find the final value of it. And as you can see that all the values are true, therefore it is a tautology. So you can say that with the help of truth table it is proved that the following proposition P implies Q implies P is a tautology. Fine. Okay, so let us come to the next question. The next question asks us to show that the negation of P implies Q is a contradiction. Now there is one thing which we need to pick up. It says that the negation of this statement. Fine. So what should be the way of solving it? You remember this expression, we have this expression and we have to solve it to be a contradiction. The negation of this expression has to be a contradiction. So one way, or the last way which we discussed in the last question, we will pick up from there and solve it. And it will be easier for us. The first thing first, what it is asking us to do. it is asking us that if we put a negation sign here, so this has to be a tautology, because they are asking us to say, solve that, show that the negation of this expression is a contradiction. So we have to first calculate the value of this and then find the negation of that value. Okay, so this is the way of solving it. Now, how to solve it? I can directly draw it, so maybe I will make it a little bit spacious for all of us to understand it clearly. The expression is like this: negation of P implies Q. Fine. And I draw another bracket over here, the curly brackets over here, and put a negation sign here. I have to find this value to be a tautology. Oh, sorry, a contradiction. This is the question. Okay, fine. So first thing first, we know that what will be the value of true? True, false, false. This is true, false, true, false. Fine. Now negation of this, we know that this is going to be true, true, false, false. So the negation of this will be false, false, true, true. Fine. So first let us calculate the value of this. So this is true, this is false, this is true, and this is also true. Fine. Now we have to find this implies this. So false implies true is true, false implies false is true, true implies true is true, true implies true is true. So we found this value. Now we have to find the negation of this value. So the negation of this value have to be here. So you see, this is false, this is also false, this is also going to be false, and this is also going to be false. So this is the table which was required in this question. So the question was saying that show that the negation of or the denial of this expression is a contradiction, and you can see that all the values are false. So this is a contradiction. Okay, now this is the next question. The next question is to find the value of this expression or this expression. Now why I am taking this example? Because there is something called bracketing. Bracketing is a very important thing. Bracketing, sometimes it is also said that you need to parenthesize, parenthesis, you know, both the expressions are used. That what is the role of parenthesis? Now if you see this expression, P implies P implies P and P implies P implies P, both of the expressions look exactly similar, except for that the brackets are placed at two different positions, right? So they are bracketed in a different way, or else all the things, in fact there is nothing, there is only P and the implication, but they are put in different fashion. So how to calculate, or why this is important for us to understand bracketing. But before we understand bracketing, because you understand that this bracket and this bracket are at two different positions. Also there is one concept called main connective. So this is another important thing. What is a main connective? Now suppose suppose somebody asks you, what is the main connective of this question, or what is the main connective of this expression? So you can see in this question the main connective is this implication. On the other hand, the main connective of this question is this implication. Fine. So you understand that there is in this question the main connective is this one, because the expression's value is basically the expression value of this. However, for this expression the value is determined by this implication. The value of this expression is determined by this implication. Now what in layman terms again, because you will find all the definitions and everything in the book. I am not here to teach you any book or something. We will be basically dealing with theoretically and what are the problems which comes in question solving and so on. So if suppose somebody asks you what is the main connective, in very layman terms, if suppose you have to answer it, it is the last connective which is operated. Last connective which is operated. If you take this question, you will put the values of P, how it will be, then P, then you will calculate the value of this, then you will calculate the value of this with this. In this case, you will put the value of P here, put the value of P here, put the value of P here. First you will calculate the value of P here, then you will calculate the value of this expression with P again, and you will write it over here. So you see that the last thing which is going to be operated is here, and the last thing which is operated in this expression is here, right? So this is the main connective, that is the last connective which is operated. In very layman terms, you can always see the definition in the book. That's not going to be a problem, right? You need to understand the concepts clearly so that when you are making a logical decision, it's the right decision or it is the correct decision as per the understanding of this part of the logic. Okay, so I remove this part, I take this out. I am also removing this because you understand that the importance of bracket is there, because, or you still do not understand the importance of bracket. You will understand it once you will calculate the value. So I am removing this because this is not going to be of any use for the time being. I am also removing this and this. So now let us calculate. Now since it's only one P, so the truth table will be only of 2 rows. You should not draw it with 4 rows and this and that. You can make it with 8 rows, you can make it with 32 rows. That's not going to be a problem, but it is going to be a problem for calculation. The work will be more dizzy by nature, right? So it should not be like this. The minimum expression which is required is something which you should adhere to. So I write true and false here. True, false, true, false. Fine. Now I need to calculate the value of this. True, true is true. False and false is also true. Now I calculate this. True implies true is true. False implies true is true. So you can see that this is a tautology. Fine. Very nice. Now let us come to this one. Again, how we will draw? True, false, true, false, true, false. Fine. Now we will calculate this value. True, false implies false is also true. Now true implies true is true. True implies false is false. Now you see this expression. This is not a tautology. In fact, what kind of expression is this? This is basically a contingent proposition, because there is true and there is false. Here you see both are true. Now you understand. If you misplace the bracket, even with the same expressions PPP, even with the same logical connective, implication, implication here, implication, implication here, the value changes. In this expression, it was a tautologous expression. Here, the expression is a contingent expression. So, this is the importance of putting a bracket. Okay, this is the last part of today's lecture. So we are having a very small thing to discuss right now, because in the last example we saw that once we misplace or once we change the position of brackets, the truth value changes of a proposition or of a statement which we are determining. The value is determined. So similarly, sometimes you need to be very, very clear about what should be the place of brackets. Now suppose if we have an expression like this, like suppose P dot Q implies R, wedge S, triple bar T. Suppose we have this expression and somebody says that okay, put brackets in an appropriate way so that this expression becomes unambiguous, right? Because right now you can see that this expression is ambiguous. Why I am saying that this expression is ambiguous? Because you do not know which is the main connective. So if you make this as the main connective or this as the main connective or this, so the expression can change, right? So you need to be very cautious about it. But there is a way to put the brackets. So before how to put the brackets, let us see what are the relative strengths of the logical connectives. We have studied logical connectives like this negation, this is and, this is or, this is implication, and this is equivalence, right? And the power of the main connectives or power of these connectives remain in this order only. Therefore, we also teach the course in this way. Now, how to put the brackets for this? Now, in this book, the convention which is followed by most logicians, including Irving M. Copy, the book which we are using, is that they use this as the first bracket, like normal mathematics. This as the second bracket, which is usually the third bracket, right, in mathematics. And the curly bracket is basically the third bracket in this course or in this logic. This goes here and this goes here usually in mathematics, but in logic or in the logic which we are following, one convention or the other you have to follow. It's just a matter of convention. There is nothing like this is the rule and something like that. It's like a convention, like some countries in this world drive on the left hand side of the road, the other people drive on the right hand side of the road, and there is nothing sacrosanct about it, that this is the rule which needs to be followed in order to achieve some target or on. But you need to follow a convention in some way or the other, and this is the convention which we are following. Okay, fine. And this is the convention which we are following, and in fact this is not a convention, in fact it is a rule, but still some people can say that it's a convention. So how to put the brackets here? Now you see that the dot has to be, like if you remember in our school days, we used to be given a formula like BODMAS, right? The bracket, the of, the division, the multiplication, the addition, and the subtraction. That means that how you need to follow, how you first put brackets, what needs to be calculated first, what needs to be calculated at a later stage. Similarly here also, you need to calculate certain things before and certain things afterward. So what should be the way of calculating these things? Now you can see that, in this expression we do not have a negation, so we do not have to worry about it, there is no negation. There is an and. So first thing first, you put a bracket here with the and, whatever is there with the and. Fine. Now you see that there is a wedge. Now you need to put a bracket here. Then you see that there is an implication here. So you put a bracket here. And then there is equivalence. So if you make the bracket like this, you find that this is an expression which has been now made unambiguous. Now how you will calculate the value of this? P, Q, R, S, T. So the table will be of 32 rows. Now you will make the truth table. First you will calculate the value of this. Then you will calculate the value of this. Then you will calculate the combined value of these two here. Then with this value you have to calculate the value of this. And the last result, whatever is going to come over here, you will say whether this proposition is going to be a contingent proposition or a tautology or a contradiction. With my limited understanding of logic, and as I can see this expression, this value will come as a contingent proposition. Fine, but you can check it for yourself. Thank you.